Section 6.2 is on similar triangles. The definition of similar triangles or similar polygons is polygons having the exact same shape but may differ in size. That little curly Q thing there means similar. It's like a sideways S. So if I look at these two polygons, they are both trapezoids, and I say A, B, C, D is similar to E, F, G, H, it means that angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, angle D is congruent to angle H. But it also means that the sides are proportional. Okay, so if I go between the 1 and the 2 little curve marks, so the measurement of AB would be proportional to EF, and that's going to have the same proportion as BC to FG, between the 2 and the 3, between the 2 and the 3, and then you have CD to GH, that's between the 3 little curves and the 4 little curves, the 3 little curves and the 4 little curves, and you have between DA and HE, that's between the 4 and the 1, the 4 and the 1. So if this is 1 to 2, this would have to be 1 to 2, this would have to be 1 to 2, and this would have to be 1 to 2. So for instance, let's say this is, I don't know, let's say this is double what that is. So let's say this is 5, this would be 10. So I would have a 5 to 10 or a 1/2. If this is 4, then this one would have to be 8. If this is 7, then this one would have to be 14. If this one over here was 6, then this one would have to be 12. Then each one of them would have a proportion of 1 over 2, 1 over 2, 1 over 2, 1 over 2 when they were reduced down, because I would have 5 over 10, 4 over 8, 7 over 14, and 6 over 12. So each one of them would reduce down to 1/2. So I would know that the sides would be proportional. So an example problem might be, they give you these two example triangles and they say determine if these triangles are similar. Well, the first thing I'm going to do is I'm going to look at their angles. So this has a 90 degree, a 30 degree, so this one would have to be a 60 degrees. So this one has a 90, 30, and this one would have to be a 60. So I'm going to mark this angle has to be congruent to that. That angle would be congruent to that. And this angle is 90, and it's congruent to the 90 over here. So I know that the sides are congruent. So now let's look at the angles are congruent. Let's look at the sides. Between the 1 and the 2 curve marks, and I'm going to do left triangle over right triangle to keep it organized. So on the left triangle between the 1 and the 2, I have a 12. On the right triangle between a 1 and a 2, I have a 9. On the left triangle between the 2 and the 3, I have a 6. Between the 2 and the 3 on that one, I have a 4.5. Between a 1 and a 3, I have a 6 on the square root of 3. Between the 1 and the 3 on this one, I have a 4.5 on the square root of 3. So you could reduce them down, or you could make a decimal value out of each and compare it. So I can go 12 divided by 9 is going to give me 1.3 with a line over it. 6 divided by 4.5 is going to give me a 1.3 with a line over it. And then these, your square roots cancel out. So again, it's going to be just like that. So I know it's going to be a 1.3 with a line over it. So these two triangles are similar. And when I would write the similarity statement, I would say A, B, C is similar to, I don't think I put that, let's put a G here. So it's similar to G, E, F. Okay, because A is with G, B is with E, and C is with F. Here's another one. I've got a 60 and I've got an 80, which is 140. So this one would have to be 40. And I've got an 80 and a 40, which is 120. So this one would have to be 60. So the triangles line up. So let me put my hash marks on there. It will definitely help you if you will draw these things and put the hash marks on there. So between, and again, I'm going to do left triangle on the top, right triangle on the bottom, and I'll write it so I don't get confused between the two. So on the left, between the 1 and the 2, I have a 5.2. On the right, between the 1 and the 2, I have a 3.9. On the left, between a 2 and a 3, I have a 7. On the right, between a 2 and a 3, I've got a 5.25. Between a 1 and a 3 on the left, I have an 8. Between a 1 and the 3 on the right, I have a 6. So let's see the decimal value for those. 5.2 divided by 3.9 is going to give me a 1.3 with a line over it. 7 divided by 5.25 also gives me a 1.3 with a line over it. 8 divided by 6 also gives me a 1.3 with a line over it. So I know that triangle A, B, C is similar to triangle R, S, T. All right. With these, you have what's called scale factors. And it's a ratio between two corresponding lengths, often comparing a new length to an old length, or a measurement on an actual item to a model. A unit, or the unit of measure, must be the same when possible. And here's an example. An architect prepared a 12-inch model of a skyscraper that looks like a 1,100-foot building. What is the scale factor of the model compared to the real? Well, this is in inches and this is in feet. But I know I can quickly take that 12 inches and change it to 1 foot because 12 inches equals 1 foot. So on the model, if I have 1 foot, it's comparable to 1,100 feet on actual. So that is your scale drawing, or scale factor, scale rate, which would be 1 to 1,100 feet. You can use similar polygons to find unknown values. So if you were looking at these, they have all the angles marked. So I can write a similarity statement. I can say A, B, C, D, E is similar, and I went 1, 2, the one hash mark, the one curve, 2 curves, 3 curves, 4 curves, and 5 curves. And then I would just have to come over here and write the 1 curve, the 2 curve, the 3 curve, the 4 curve, and the 5 curve. So A, B, C, D, E is similar to R, S, T, U, V. And it asks me to find X, Y, and Z. So I look at these, and again I'm going to write left over right so I know what I'm putting where. So the measurement between the 1 and the 2 curves over on the left is 6. Between the 1 and the 2 on the right is 4. So then I can use that to solve for these other things. Between the 3 and the 4 on the left is X. between the 3 and the 4 on the right is 3. So now I cross product and I solve. So I have 4x is equal to 18. I'm going to divide by 4. And I'm going to get x is equal to 9 over 2, or 4.5. So that's my x. My y is down here at the bottom. So again, I can do 6 is to 4 as 8, because it's on the left one, is to y plus 1. I cross product. Have to do distributive property on this one. So I have 6y plus 6 is equal to 32. I'm going to subtract 6 from both sides. So I have 6y is equal to 26. I'm going to divide. And I'm going to get y is equal to, let's see, if I divide the top by 2, I get 13. Bottom by 2, I get 3. So 3 over 2. And then I have to do z. I think I forgot to put z on there, so you can't find z on this one. So we found the x and the y. Your homework on this is page 293 through 295, 11 through 14 all, 17 through 20 all, and 34 through 38 even.